Welcome to Snark Chocolate, a show about cryptography products where we break them down with rich flavors and sweet insights. I'm Omer, and I'll be co-hosting this episode together with Queenie. Today we're thrilled to be joined by Ravital Solomon, founder and CEO of Sunscreen, a privacy engine for the new web. Ravital, it's great to have you on the show. Can you share with us a bit more about your background and how you came to work on Sunscreen?
Yeah, it's so great to be here. So, my background is in something called lattice-based cryptography, which you can think of as the foundation of fully homomorphic encryption. It's a special type of cryptography that's post-quantum. I became interested in it while I was doing my math undergrad at Berkeley, and I've never left the area since. It's just been an evolution in terms of the exact types of problems I work on. So, started making the transition to more applied-based cryptography during my master's, was in the crypto space. I've always worked in the cryptocurrency space professionally at NewCipher. And pretty organically, out of some of the work at NewCipher on privacy preserving smart contracts, it ended up transitioning into what is Sunscreen, where we're working on making FHE extremely fast and extremely accessible for developers that are non experts in cryptography.
Right. So you just mentioned that you're working on making FHE, fully homomorphic encryption, accessible to developers. And I wonder if you can tell us more about the challenges in doing so.
Yeah. So when I first started looking at fully homomorphic encryption, it was when I was at NewCipher. And at that point in time, the developer experience was extremely challenging. So, say you wanted to build an application using fully homomorphic encryption, you needed to know quite a bit about the underlying cryptography itself. So, you had to think about things like picking all of these security parameters, picking parameters that affect performance, and you really needed to think about as well, like, how do you structure the program in a way that makes sense for this technology? So if you're familiar with ZK, you can think about it a little bit like having to write ZK circuits. It's an extremely like specialized group of people who can do that. So FHE at that point in time, and I would say some of that experience is still there today, really requires this expertise in the underlying cryptography as well as setting up circuits in a really efficient way. So the main challenge for developers is thinking about their program in light of FHE in a way that can be performant as well as secure.
So how close is FHE to becoming practical? And you can give your own interpretation of what practical means.
I think this is an extremely funny question, and I guess get asked it all the time by like potential hires, engineers, investors. And when I think most people use the term practical, what they're actually trying to say is widespread. Like if FHE is the holy grail of cryptography, presumably it should be used in a number of applications that are deployed and in production today. And that's like a fair point. So I would say it's practical in the sense that Apple has deployed FHE in two major applications, and there are over a billion iPhones out there today. So, in some sense, FHE already is practical. But if you mean when is FHE going to be widespread, I think there are a few challenges on that side. One is that the technology is not quite performant yet to handle a lot more interesting use cases. Two, it's extremely difficult for developers to integrate the technology, which prevents adoption. So that's part of the reason why it's not widespread today. And three, there is a lack of standardization, particularly on the NIST side, which hinders adoption quite a bit when we're thinking about Web 2 and more traditional use cases.
Yeah, I understand now that asking about practicality is indeed can be confusing. And but you did mention that Apple is already using FHE. Can you maybe elaborate on the use cases where this is being applied?
Yeah, so I certainly don't work at Apple with like that very obvious disclaimer, but from my understanding, there are two use cases where Apple has deployed FHE today, particularly the BFV scheme. So there is the caller ID lookup, as well as some sort of image search or image recommendation product. I think that's a combination of the BFE scheme along with like differential privacy. But there is FHE in production in systems today. It's just extremely specialized.
Yeah, I guess my problem with Apple is that it's very hard to tell what exactly is happening under the hood. Um, but yeah, I mean to back to the point on practicality, it's indeed like when do you know when something is widespread? What are going to be the signs? So that's a good question. And one way I want to try and answer it is from the lens of what you guys have been seeing and building so far. So Sunscreen has been building FHE for a few years now, and I wonder if you can try and give us some kind of idea about the changes that happened during this period of time to the tech stack of fully homomorphic encryption.
Yeah. So, more generally speaking, when we're thinking about the evolution of FHE from, we'll say, kind of late 2021 till now, there hasn't been that much development on the FHE schemes themselves. So, we still have the same FHE schemes as we did back 4 years ago. What has changed is that there have been some improvements to this technique called bootstrapping, which is essential to actually doing unlimited computation over encrypted data. There have been some improvements when you're thinking about how to construct a threshold fully homomorphic encryption scheme. So when you're thinking about like how do I do this key generation process and decryption process, and there have been some improvements on the ZK side, which relates quite a bit to FHE when we're thinking about using this technology in the context of blockchain. So, how do we prove things about ciphertext? How do we prove a computation was done correctly? There's definitely been some advancements on the research side there as well.
Okay, so I take from that most of your work is focused on engineering and like engineering this like FAG systems. So one of the main issues that, at least for me, seems to be something that maybe prevent this widespread for now is performance. And I'm curious if this is like maybe you can share how you guys are like tackling like this tough engineering um, challenges around performance.
Yeah. So I would say there are two major things that we focus on at Sunscreen. One of them is performance, as you've suggested. The other part is usability. So on the performance end, there have been a few advancements we've done that are partially engineering, partially R&D, and we've submitted a research paper recently to a conference about this. So on the performance side, we've been pioneering the use of a particular bootstrapping technique called circuit bootstrapping. And what's special about this technique is that we believe it offers a lot more parallelism when doing FHE computations. So that is one way we've helped with performance. We've seen performance improvements, assuming you are running the computation on a fairly large machine. So generally, when we say a fairly large machine, we're thinking like 64 plus cores. So that's one way we've dealt with performance on the research side. Um, Additionally, we've been working on a GPU accelerated version of our FHE library, and we've been tackling this dual problem of usability and performance through one of our latest offerings, which is a FHE compiler that under the hood has a virtual processor, and specifically, it's an out of order processor. So that allows us as well to extract a little bit more performance, a little bit more parallelism out of the FHE computations themselves today.
Ravital, since you mentioned usability, maybe can you walk us through a concrete example of a use case? Like how would a developer set up the service and what experience might they expect today?
Yeah. So if we're talking about what experience we would like the developer to have specifically and what does it look like with our product, Parasol, we would like the developer to write a program in a language they're already comfortable with And we also assume that the developer may not be a crypto native. So they might not know Solidity, for example. So to us, the goal is that developers can bring their own program, meaning, say they have a program already written, they haven't thought about privacy or cryptography. How can we let them take that program and transform it into a FHE program? So specifically, if we're thinking about a auction, which is one use case we often get asked about, today the workflow looks like the following. The developer has their program, their auction program. It's written in C because that's the first language we support. It has no privacy at all. The developer doesn't know anything about cryptography. So they now want to transform it into a encrypted auction, meaning an auction that runs over encrypted bids. They are going to add some directives to their program just to indicate the inputs now need to be encrypted. And then they're going to compile it using a modified version of Clang, which is the C compiler. And that's what the rough workflow looks like. So the goal really is for developers to not rewrite their program, but to just make some small additions to an existing program they may have already written.
So we just mentioned a few interesting products, and maybe we can take one step back and you can explain to us about the vision for sunscreen and product strategy.
Yeah. So in terms of SPF, which is the Secure Processing Framework, it's the main product we work on in Sunscreen. It came from three core beliefs that we had. One was that developers should be able to bring their own program. They should never have to rewrite a program or restructure it to take advantage of this technology. Two, the next tenet we had was that the same FHE program should be able to be used in Web 2, Web 3, any chain. There should be no need to ever rewrite an FHE program if you want to be in Ethereum, Solana, Sui. And then finally, based on all of the experience I've had in FHE and how I've seen it evolve, I really wanted to create a framework that was extremely modular with the belief that there may be new advancements in FHE. Maybe it'll come from our team. Maybe it'll come from someone else. Maybe there'll be advancements on the ZK side, and maybe we're going to have to swap out pieces. So they should all be able to be swapped out with fairly short notice. In terms of SPF itself, we are extremely opinionated on how FHE should be made performant and what the developer experience should look like. But we don't believe in taking a stance in terms of who is going to write the first set of killer apps. Is that going to come from a Solidity developer, or is that going to come from somebody in Web 2? What chain is it going to be on? I think it's very difficult to say definitively where that'll happen as well. So we've built a product that does not take a stance in terms of a killer app being created by a Web 2 or Web 3 dev or where it might live.
Maybe it would be useful to walk us through a concrete use case. So you mentioned the auction, but maybe now you can couple it with SPF. How SPF is gonna be applied here?
Yeah. So SPF under the hood consists of two main stacks. We have the computing stack, which is our FHE compiler, nicknamed Parasol. So right now, most people are working directly with Parasol, but in the future, they'll be working with SPF. So that's the experience in terms of writing and creating a program and getting it to be super performant. There are a few other services you really need when you're thinking about deploying and using a FHE application, whether it's in Web 2 or Web 3. So one piece has to do with access control and making sure only the right people are accessing plain text data, as well as thinking about if you're using threshold FHE, where there's different parties working together, who is managing that interaction, how is the key distributed? So that service as well is included in SPF.
Oh, so SPF is also for key management.
SPF is like the full service offering. So, in terms of what I think about what Sunscreen is building, we're building SPF. That is our singular product. But under the hood of that product, there are sub products, which consist of an FHE compiler, an access control system, and the key management system.
So I feel secure processing framework is a very powerful concept. So Ravital, would you consider maybe also using other cryptography technologies? Because you just mentioned ZK, and I'm curious then how would different technologies add values to each other and how they would integrate with each other?
So, when you're thinking about using FHE, particularly on chain today, you often do need ZK to use FHE in what I would say is like a secure way, meaning you want to make sure that when someone is requesting a decryption of a ciphertext or putting a ciphertext on chain, that they know what the underlying plain text is. So that's really where the ZK piece comes into play, and we would expect that's part of the SPF offering. The other aspect is MPC, and that comes into play when we're thinking about okay, if we want to create like threshold FHE, we need to distribute the key. There's this decryption process that is somewhat interactive. That is where MPC comes into play. So, SPF, the main compute is done via FHE, but some of these auxiliary services are enabled using ZKPs as well as MPC.
That's really helpful. And I found that it seems there's also a ZK compiler.
Yeah, so a little bit earlier in the company's life, we were pretty interested in making FHE and ZK together very easy to use. So at that point in time, we were building both an FHE compiler, but it was for a different FHE scheme than the one we work on now. It was for the BFE scheme that Apple currently uses as well. And we had a ZK compiler with a ZK system that at the time was state of the art and now is no longer state of the art, which indicates how quickly cryptography moves. But we do not anticipate for SPF itself that there will be a ZK compiler. That is something we've kind of kept up for academic purposes, but not something that'll be part of our current offering.
Got it.
So the FHE compiler, what makes it unique? How is it different from a regular compiler?
Um, In terms of like how is it different from a regular compiler, that one is a bit trickier of a question to answer. In terms of how it's different from other FHE compilers, that's a bit easier of a question. So I'll answer that one. Two major ways I would say it's different from all existing FHE compilers. The first is the architecture. So we have an LLVM based compiler, and that is pretty unique. I don't believe any of the existing FHE compilers take that approach, which is what enables us to allow developers to write their program directly in C, not some kind of embedded DSL. The other part that's unique about our FHE compiler is that it has a different homomorphic computing paradigm than any of the existing FHE compilers. So we make use of a special bootstrapping technique called circuit bootstrapping, and we combine that with a homomorphic version of multiplexers to enable arbitrary computation. And as far as we know, we're the first people to really pioneer the use of circuit bootstrapping in any FHE compiler.
And so is that going to work on CPU and GPU?
It's a virtual processor, and yes. So right now, our first hire, who is a GPU guy, is working on a GPU accelerated version of our scheme. And yes, it will work with Parasol. Today, Parasol just works on CPU, and you really need sufficient cores to see a performance improvement. So we request folks use a machine of at least 64 cores today.
Maybe a stupid question, but I remember that with FHE schemes, you have like a lot of parameters you need to set up. Um, this is something you guys are handling as part of the compute, or as part of Parcel.
That's correct. So I think what you're potentially thinking about is depending on which FHE scheme you're working with. Sometimes you want to choose the parameters based on the program the developer writes. So like that is the case with say like the BFE scheme. So we as the experts would have to pick the parameters if we know what the developer is intending to run. That's not so much of a problem when you're working with like CGGI based schemes. So like that's a class of schemes that people think of as working, we'll say, with binary gates. It's a bit of a simplification, but that's maybe the simplest way of thinking about it. So we handle parameter selection, and that's something that is hard coded. And we have selected parameters to provide 128 bits of security.
Got it. Got it. Okay, that's exciting. So, yeah, Ravital, so maybe you can share what's on your roadmap.
Yeah, so there's a number of things on our technical as well as go-to-market roadmap. On the technical side, we are working on a GPU accelerated version of our FHE library. We are also implementing a new threshold scheme to work with our FHE library. We are also in the process of building out our access control system. On the go-to-market side, we've been working on integrating our tech stack with a number of different use cases, both on blockchain as well as off blockchain.
I see. So it's like so you have SPF and which is this like concept in a sense that you're still pouring like R&D into it and improving it. That's the way to view it.
Um, Probably not quite that. So we know what SPF is. We know exactly what it should look like, but all of the pieces haven't been fully built out yet. So we're still building out an access control system that we're happy with, and we wanted to change how we do threshold FHE there. So today, what folks are integrating and working with is the smaller subset of SPF, which is just Parasol.
So going back to the practicality question, um, maybe now that we've learned a bit more about your approach, we can try and make it a bit more concrete, asking about like existing challenges with fully homomorphic encryption. Right. So, for example, I mean, if I'm a developer now and I want to use this technology, right? So what's missing, or what's going to be my top something like pain points?
So the main pain point we've seen is now on the performance side, that even if we improve the developer experience, developers tend to get pretty shocked with the performance they see when they create most FHE programs today.
Okay, so it means that this is also your top priority is to keep pushing performance, GPUs, and whatnot.
Yes. So when I think about our company's mission, we always do want to iterate on the developer experience. I think there are still ways that we can improve that quite a bit. But the main priority is really on the performance side at this point in time because it's a pretty large hindrance to adoption.
What about the key size or some kind of like network issues, bandwidth? Does that exist today, or it's like irrelevant?
We haven't seen too many problems on ciphertext or key size issues simply because there are existing ways to kind of get around that, whether it's like hashing a ciphertext and just putting a hash on chain. So to me, I would say that's of a much lower order magnitude than working on performance itself, which is the main blocker we found to adoption.
Ravital, so the current SPF seems to take a more chain agnostic approach. Do you still foresee maybe launching a specialized FHE powered blockchain?
So for us, we really want to have developers adopting this technology and asking them to come to some very specialized chain is not in the best interest of the field or adoption of the technology itself. So we really think about bringing FHE to chains where there are tons of users, tons of developers, there's quite a bit of TVL, rather than asking them to move over to any new chain that's created.
So you've managed to build all of this, what seems to be a very complex system with a relatively small team. Um, Comparing it, for example, to Zama, which I think also in this like space of building dev tools for polymorphic encryption, they are now a huge company, like a unicorn. So I wonder how do you manage to do it with such a small team? What's the playbook?
So I would say there are two major pieces. I'm extremely picky in terms of hiring, and we tend to reject a lot of hires. My belief is that we should hire the best technical people possible, as well as hiring people that are cryptography outsiders. We've given cryptographers sufficient time to commercialize the field, to bring it to enterprise, to bring it to production, and they haven't succeeded so far. So it's really important to bring people from outside of the cryptography space that are extremely smart and technically gifted and enable them to bring the technology to a wider set of people. So when we think about hiring, I always hire people that are smarter than me. I specifically hire people from other technical domains, and we teach them cryptography as part of the job. And then we really give them ownership. And that's led to some of the interesting things we've done here when we think about like this new homomorphic computing approach using circuit bootstrapping or this LLVM based compiler. That's thanks to having people that are not trained as cryptographers. The other aspect is that because we're so small, we have to be ruthlessly focused on only one thing at a time. So if we don't believe we have an advantage in a specific area, we don't go after it. So I don't believe personally we have any advantage on the ZK side. If there's a good existing system, we might as well use that. But when we have a belief and when we believe we have an advantage, we go all in. So we did believe that we could outperform the existing state of the art in the FHE side, but it would take quite a bit of work. So we went all in on that. And we believed we could improve the developer experience with the LLVM based approach. So we went all in on that as well.
So thanks for sharing, Ravital. I wonder if you can also share more of like a high level comparison between Sunscreen and some of your competitors. You already mentioned that you have a different way of doing FHE compiler, so it means that there's a category here of FHE compilers, and I wonder if there are like other things you guys are doing differently.
Yeah, that's an interesting question. I would say the consensus in the FHE field today is that people should have to rewrite their program to take advantage of the technology, which to us doesn't quite make sense. And we don't agree with that belief. The other one is essentially using what is popular on the homomorphic computing side. So there are certain techniques that have been suggested in the literature to be state of the art, and most folks just take other people's word that this is the best way of doing homomorphic computing, this is the best way of doing FHE, rather than, I would say, critically question if there are other approaches. So those are the main two ways I would say we really differentiate ourselves from the other people working in the space.
Got it. Um, so I've been cheerleading for Sunscreen, I think from the very, very early days. However, recently it feels like there are like way more of us out there based on kind of like the sentiment I get from on social media cheering for you guys. So maybe can you tell us if like what changed over time?
A lot has changed, I would say, in the last 6 or so months. So we have our latest research work, which has definitely got us quite a bit of interest from a variety of partners as well as researchers. We have been working on a number of partnerships and integrations of our tech. And to be honest, we've also brought on a new person to the team who's operating as COO, who's really prioritized marketing, which is something we hadn't been focused on in the past. So I would say, like, those are the couple of things that have really moved the needle in the last 3 to 6 months.
Yeah, it's great to see. Can you share more about some of your partnerships? Specifically, I've seen a recent announcement on a collaboration with Monad. Maybe you can share more details on that.
Yeah. So we really like the Monad ecosystem because they have this set of really engaged developers as well as community members. And they also think about performance in terms of like throughput, latency, having like shorter block times. So we really felt it could be a good place to first push our product. And one of the other reasons we really ended up in Monad is via Primus Labs, which I believe you've done a podcast episode with before. And we really, really adore their team. So, one of the first partnerships in terms of actual use cases and not just like, excuse my language, like bullshit infra on infra is payments. So, how do we enable people to do private payments and make that experience friendly to non crypto native audiences? So that really tied in with our partnership with Primus, where they enable you to send crypto to somebody, even if they don't yet have an address or you don't know what their address is. And we have added our technology in to enable that to be done privately.
Super interesting. Is it live already?
Not yet. So we are in the final stages of integrating it on Monad first, and we'll be looking at a few other ecosystems for this as well.
So, Ravital, FHE, future, 5 years from now, let's say, or some other kind of like long-term future. How do you view it? How is it gonna look like a few years from now?
I imagine FHE will be in production across a pretty large variety of apps. So, kind of what you were asking me before about like, is FHE practical? And I'm pretty sure by practical, you mean widespread. So, yes, in 5 years, I believe FHE will be fairly widespread and deployed in a number of use cases, both on and off chain. I also believe the developer experience will be significantly improved from what it is today. So, there'll be much less performance issues, as well as it'll be a lot easier to create applications. And hopefully that'll be using Sunscreen's technology.
Do you think that this concern for privacy would get enhanced due to the growing usage of AI? Like AI is, you need a lot of like data to do AI. So these AI systems know quite a lot about us. Do you think that like the AI companies are gonna figure out ways to adopt FAG to make it used also for like these very large systems?
Yes, but we definitely need specialized hardware to drive adoption in that area. I think another important angle in terms of adoption of the technology is standardization around it. So currently, there is a NIST call for multi party threshold systems. And if I'm not mistaken, the kind of ask to start transitioning to post quantum cryptography depends in terms of the industry people are working in, but the expectation is for people to move over in the next 5 to 10 years. So, with that push to move to a post quantum world, I do expect FHE as well to have more widespread adoption.
Yeah, let's hope so. Privacy is good. Yes, I think that with that we can move to our final question. It's a question that we ask all of our guests, and it is if you can name a project that you are bullish about.
It's so biased, but I really would have to say Primus Labs. I think they combine like having this amazing R&D team on the ZK TLS side with being extremely go-to-market focused as well as extremely responsive. So I would do the shout out to Primus.
Yeah, well deserved. Great. So, Ravital, thank you so much for joining us today. I think that it was super informational, and we learned a lot about sunscreen. I will add some links for those that are interested to learn more, how to get in touch, and to read about the technology and products. So yeah, thank you, Ravital.
Thank you.